Good afternoon, one and all. I welcome you all to Ganesh IAS Academy. In today's session, we'll be seeing environment-based current affairs from the date December 1st to December 12th, 2023. Let us get into the news articles one by one. The first news that we are going to see for today is methane reduction plan outlined by World Bank. So, what was the methane reduction plan outlined by World Bank and why has World Bank done this? And what is the need for such a plan? All these details we must have to understand in this particular news article. Let us get into the details. Methane reduction plan outlined by World Bank. Okay, so in an initiative to combat the rising methane emission, the rising threat of methane emission, the World Bank has announced plans to launch a series of country-led programs. So it will be country-led programs. Many countries will be asked to lead programs. Okay, and then the World Bank is set to roll out a minimum of 15 country-led programs. So a minimum of 15 country-led programs will be rolled out by the World Bank, and this will be done in the next 18 months. And these programs will specifically target methane emission. Obviously, it is for the methane reduction only, and then it will target methane emission. And according to World Bank, this move is a step in addressing the alarming increase in global temperatures. Okay, this methane emission is causing increase in global temperature. That is because it is a very potent greenhouse gas. Okay, so it is causing increasing in global temperature, and this step or this move is also helpful in supporting communities who are most vulnerable to impacts of climate change. So they will be focusing in supporting the communities who are most vulnerable, and then it is also a step in addressing the alarming increase in global temperature. So this is what we need to know. What else we must have to understand from this news article? Why is there a need for such a plan by World Bank? That we need to know. So here we'll be understanding about how potent this methane is as a greenhouse gas. All those details we must have to know. So methane accounts for approximately 19% of the global greenhouse gas emissions. So it accounts for 19% of the global greenhouse gas emissions, making it a substantial contributor to the climate change. And then what are all the sources of methane emission? The major sources here. So the major sources are rice production, which accounts for 8% of methane emission, livestock, which accounts for 32%. Okay, those cattle, they are responsible for 32% of global methane emission, and then waste production or waste generation, which leads to 18% of the total the methane emissions here. Okay, all these are human driven. Okay, and thus making targeted efforts in this area is crucial. So we need to take targeted efforts in reducing methane emission from these areas, that is rice production, livestock, and then waste generation. Okay, next, methane has a much higher global warming potential than carbon dioxide. We talk a lot about carbon dioxide whenever there is a discussion about global warming, then the discussion goes about carbon dioxide, but then there are many other potent greenhouse gases which contribute or which is more harmful than carbon dioxide. Okay, so this methane is having much higher global warming potential than carbon dioxide. And see the level, despite methane being 80 times more potent than carbon dioxide. So it is 80 times more potent than carbon dioxide in terms of warming the planet, and it has received less attention and finding. Okay, so more attention is given to carbon dioxide, but less attention is given to other gases, other greenhouse gases. Okay, so since it has received less attention and funding all these years, World Bank is taking this effort to address this issue. Okay, what else do we have to understand? We saw something called as global warming potential, right? We must have to understand that in furthermore detail. Okay, so what is this global warming potential? Global warming potential is a measure of how much heat a greenhouse gas traps in the atmosphere. over a specific time period. Okay, and usually this time period is fixed for 100 years. Okay, and all this is in comparison to the carbon dioxide. This is also important. So when we talk about global warming potential, then if global warming potential for a particular gas is discussed, then it is discussed only in comparison with carbon dioxide. This is what we need to know. So it is a measure of how much heat a greenhouse gas traps in the atmosphere over a specific period of time, usually 100 years. Okay, and it is used to evaluate and compare. So individual evaluation is also there, and then comparison is also there, because every other gas here is compared to carbon dioxide's potential. Okay, and here carbon dioxide is the reference gas with global warming potential of 1. Okay, and then other gases such as methane and nitrous oxide have higher global warming potential because they are more effective in trapping heat. So here the measure is how much of heat is trapped. That is the measure that they are going to identify. Next is the Intergovernmental Panel on Climate Change, that is IPCC, provides this global warming potential values for different gases. So which is the body or which is the organization which is giving this value? It is the IPCC, Intergovernmental Panel on Climate Change. And it is important to note that this GWP, that is global warming potential values, can vary depending upon the time horizon chosen for the comparison. So generally it is said that it is chosen for the time, I mean it is measured for the time horizon of 100 years. But then if this time horizon varies, then accordingly the global warming potential will also vary. This is what we need to know. Okay, now we need to understand about the plan set by World Bank. Okay, so World Bank's triple win approach. So World Bank is saying that they are having a triple win approach. What is that triple win? That we need to know. So the ambitious programs will focus on slashing methane emissions. Obviously, it is for methane emissions from various sources, including rice production, livestock operations, and waste management, with 3 major areas. Okay, and then the comprehensive approach to methane reduction outlined by World Bank emphasizes triple win. What is that? First thing is reducing emission. Reduction in emission must be there. Enhancing resilience. Okay, so if at all we are getting affected by methane emissions, how can we come back from it? Okay, how can we come back to normalcy from the impact? Okay, and then empowering livelihoods, this is also important. Okay, so these are all the 3 areas which the World Bank is focusing, and they are calling it triple win. Next, what is the funding mechanism? So currently, finance for methane abatement constitutes less than 2% of the global climate finance. Okay, so global climate finance will be there, and of that, only 2% is dedicated for methane abatement, but this has to increase. Okay, so the World Bank envisions a substantial increase in financing for methane reduction through public and private sector channels between 2024 and 2030. So they are going to rope in public and private sector both. Okay, and here World Bank is set to collaborate with countries like Germany, Norway, United States, and UAE, and also other private sectors to implement effective solutions and to reduce methane emissions across entire energy value chain. So they are going to collaborate with companies, and they are going to collaborate with countries, private sector and the public sector. Okay, so this is what we need to know, that World Bank is envisioning to increase the finance. Okay, next is there is something called as partnership platforms, which has been evolved by World Bank here. Okay, so complementing its efforts, World Bank is launching 2 partnership platforms. What are they? The first one is the Global Methane Reduction Platform for Development, which focuses on methane abatement in agriculture and waste management. Okay, so in agriculture and waste management sector, they have one platform, that is Global Methane Reduction Platform for Development. The other platform here is Global Flaring and Methane Reduction Partnership. Okay, so it is concentrating on reducing methane leaks in oil and gas sector. So the second partnership focuses on reducing methane emission from oil and gas sector, whereas the first partnership focuses on reducing methane emissions from agriculture and waste management. Okay, so this is what we need to know from this particular news article. The topic that we are going to discuss now is shoreline changes across entire Indian coastline. So across entire Indian coastline, shoreline is changing. So we need to differentiate between the terms like shoreline and coastline here, and why are shoreline changing and what is the trend, which state is showing more change in coastline, more change in shoreline, and all these details we will be understanding in this news article. So, the Union Minister of State for Environment, Forest and Climate Change shared insights on shoreline changes across the entire Indian coastline from multispectral satellite images. From where did he give this insight? From multispectral satellite images and field survey data from 1990 to 2016, which was conducted by National Center for Coastal Research, NCCR. Okay, so this NCCR or National Center for Coastal Research is an attached office of the Ministry of Earth Sciences. Important. Okay, questions may be asked from such areas also. Okay, this information is given by Ministry of the Minister of Environment, Forest and Climate Change, but then this body, this National Center for Coastal Research, it is an attached office of Ministry of Earth Sciences, and it has been mandated to carry out all multidisciplinary research under the central domain, and it includes areas like marine pollution, coastal processes and hazards, coastal habitats and ecosystem, and capacity building and training. In all these areas, the research will be carried out by this body or this center, that is National Center for Coastal Research. Okay, so what else do we have to understand from this particular news article? The observations of NCCR regarding coastal erosion. Okay, so what are all the observations? First thing is, some stretches of Indian shoreline are subjected to varying degrees of erosion due to natural causes and anthropogenic causes. So here both natural causes and anthropogenic activities are included. Okay, so the shoreline analysis suggests 34% of the coast is eroding and 28 is accreting and 38 is in a stable state. So erosion is land is getting, there is no development of land. Okay, whereas accretion means there is development of land. Okay, because of the deposition of alluvium. Here it is eroding. Okay, next is 38% is in stable state. Okay, so you must have to understand the difference between what is erosion and accretion. Accretion here means addition of land or deposition of alluvium near the coast. Next is, state-wise analysis suggests that in West Bengal and Pondicherry, coastal erosion exceeds more than 50%. See the levels. In West Bengal it is 63% and in Pondicherry it is 57%, which is followed by states like Kerala and Tamil Nadu, where here Kerala accounts for 45%. 45% of the Kerala's coastline, shoreline is eroded, and then in Tamil Nadu it is 41%. Here Orissa is the only coastal state which is having more than 50% of accretion. Okay, so here there is development of land or deposition of alluvium. Okay, so only in Odisha, that is 51%, where we are observing accretion. Next is, receding coastline will cause loss of land or habitat, and then livelihood of fishermen is also affected here in terms of losing their space for parking boats, mending nets and fishing operations. So when the coastline, when the shoreline is receding, then all these problems are occurring. Okay, so what features does coastal erosion cause. So these are all the different features, geographical features that coastal erosion causes. For example, beaches will be developing, and then sea cliff will be developed, marine terraces will be developed, sea cave, sea arches, sea stacks, bay and headland. All these things will be developed because of coastal erosion. Next, we need to understand about the difference between coastline and shoreline. We are talking about coastline and shoreline, but what is the basic difference between these two terms? First is coastline. Coastline refers to the boundary where an island or continent ends. That is, it is the end of the continental plate. Okay, continental plate, oceanic plate. Okay, when the where the continental plate ends and then oceanic plate starts, that line is called as coastal line. Whereas what is shoreline? Shoreline refers to the area where the land meets water. So it is merely the line where land meets water. It is a dynamic zone. That is because there is constant tides and sea waves. So it is a dynamic zone that is consistent, that is constantly changing due to natural processes such as erosion and deposition. Okay, so this is what we need to understand between the difference between what is coastline and shoreline. Here coastline is the end of the continental plate and shoreline is simply the line where land meets water. Okay, next is, what are all the government efforts or government measures to combat this coastal erosion? First thing is, we have something called as hazard line. Okay, so the Ministry of Environment, Forest and Climate Change has delineated hazard line for the entire coast of the country of India. Okay, so what is this hazard line? It is indicative of the shoreline changes. So hazard line is indicative of shoreline changes including sea level rise because of climate change, and this line is to be used by agencies. Okay, this hazard line is being used by agencies in coastal states as a tool for disaster management, including planning of adaptive and mitigation strategies. Next is hazard line. This hazard line features are actually included in this new coastal zone management plans, and this has been approved by Ministry of Environment, Forest and Climate Change. So this is what hazard line is. What other measures have the government taken? Coastal Regulation Zone Notification 2019. Okay, so the Ministry of Environment, Forest and Climate Change has notified Coastal Regulation Zone Notification 2019. Why? To conserve and protect coastal stretches, marine areas, and also to ensure livelihood security to the fishermen community and other local communities there. And then there are also no development zones under this coastal regulation zone. What are no development zone? Where none of the infrastructure activities are allowed. Okay, so the notification also provides for no development zone along various categories of coastal areas. Why? To protect India's coastline from encroachment and erosion. Okay, and then there is also another measure, that is Coastal Management Information System, CMIS. What is this? It is a data collection activity. So why is this data collection activity carried out? To collect near shore coastal data which can be used in planning, designing and construction and maintenance of site specific coastal protection structures at vulnerable coastal stretches. So it is a data collection activity. That is what we need to know. CMIS, that is Coastal Management Information System. So these are all the measures taken by the government to combat coastal erosion. Okay, so this is what we need to know about this particular news article. The topic that we are going to discuss now is meeting cooling demands while cutting emission. So what is this cooling sector? What are all the cooling demands that we have, and how are we going to meet those cooling demands while also cutting emissions, and why has this been in news? All these details we must have to understand. Let us get into the details. So the United Nations Environment Program, that is UNEP, has proposed an action plan which is aimed at significantly reducing emissions from the global cooling sector. Okay, and this action plan has been released in the recent report of UNEP, which is titled Keeping It Chill, How to Meet Cooling Demands While Cutting Emissions. Okay, so Keeping It Chill is the title of this particular report, which has been released by UNEP. And then the report is released in support of two organizations or two bodies. What are they? First one is Global Cooling Pledge, which is a joint initiative between United Arab Emirates, and then there is also another body, that is Cool Coalition. So first is Global Cooling Project, and then the next one is Cool Coalition. Okay, so now we have to understand what this Cool Coalition is. The Cool Coalition is a global network of partners working to provide efficient climate friendly cooling for all. So we need cooling, we need refrigerators, we need air conditioners. Okay, so it is a global network of partners who are working to provide efficient and climate friendly cooling. Okay, all those cooling appliances that we are using must be efficiently working, and then it must be climate friendly. That is what the focus is here. So this is a body which has been launched by UNEP. Okay, so UNEP launched this Cool Coalition at the first global conference on synergies between 2030 Agenda for Sustainable Development Goals and the Paris Agreement. Okay, in this conference only, this Cool Coalition was launched by UNEP. And then, is India a member of this Cool Coalition? Yes, India is a member of this Cool Coalition. Okay, next is what UNEP has proposed. Okay, so the proposed action plan for sustainable cooling. First thing is nature-based solution. The first recommendation that has been given by UNEP here is nature-based cooling. So it has recommended inclusion of passive cooling measures. What are all the passive cooling measures that we know? Example, shading, ventilation, insulation, green roofs, reflective surfaces, and introduction of nature to the urban areas. In urban areas, we must have to plant more trees. That is introduction of nature. Okay, so these passive cooling can reduce the need for mechanical cooling and save energy and emission. Okay, so these are all the changes which we can do. So instead of going for mechanical cooling, natural cooling processes can be adopted. Next is efficiency standards. Higher efficiency, energy efficiency cooling can reduce the energy consumption and emissions of cooling devices, and also lower the cost for the users and the utilities. Okay, so we are using cooling mechanisms. Even if it is mechanical cooling, it has to be energy efficient. That is what the focus here is. Next is what is phase down refrigerants. Okay, so phased down of refrigerants. So this refers to the use of alternative substances to cool devices. Okay, so there are cooling devices which is using harmful or potent greenhouse gases like hydrofluorocarbons. Instead of using such greenhouse gases, we can go for alternatives like hydrocarbons, ammonia, or carbon dioxide. Okay, so these HFCs, what are HFCs, that we need to understand, right? So what are HFCs? HFCs are a group of synthetic gases primarily used for cooling and refrigeration process, and then they are classified as super pollutants. HFCs or hydrofluorocarbons are classified as super pollutants. That is because of their capacity to trap heat, which is hundreds to thousands of times more than the capacity of the carbon dioxide. Okay, the global warming potential here. Okay, and despite their significant impact, they are short-lived climate pollutants. Okay, though they are very potent, they are highly potent, but then they are short-lived climate pollutants with an average atmospheric lifespan of just 15 years. Whereas when we compare it with other gases like carbon dioxide, they have this lifespan, atmospheric lifespan of 100 years. Okay, next is low global warming potential refrigerants can contribute to phase down of HFC under the Kigali Agreement of Montreal Protocol. Okay, so we have something called as Montreal Protocol. and then there is an amendment to it called Kigali Amendment. Okay, so all this will be coming under ozone protection. Okay, so for ozone protection, we have a protocol called Montreal Protocol, and there is an amendment to this protocol called Kigali Amendment. This focuses on reducing the use of hydrofluorocarbons. Okay, so when we go for alternatives for hydrofluorocarbons, then obviously it will contribute to phasing down of these chemicals under this amendment. Okay, so this is what we need to know. Next is, we were discussing about, we are discussing about cooling sector, but then what cooling sector is and how much does it contribute to global warming, this we need to know. So the cooling sector plays a crucial role in combating rising temperatures. Okay, so we are facing rising temperatures, it has to be combated, and we are employing cooling sector here. Okay, so this is useful for ensuring food safety, industrial cooling processes, and other productive economies. It also drives other productive economies, but without intervention, okay, we cannot be mindlessly using these cooling devices. Okay, so without intervention, the growing demand for cooling equipment could lead to substantial increase in electricity consumption and emission. So this has to be avoided, and the cooling sector accounts for a substantial 20% of the global electricity consumption, very high. Okay, and then if current policies continue without any intervention, then the installed capacity of cooling equipment globally will triple, which will result in more than doubling of the electricity consumed by the year 2050. So this is what we need to know. Okay, so we need to intervene here and take steps to reduce the electricity consumption by the cooling sector. The topic that we are going to discuss now is DL vertical migration. So what is this DL vertical migration? So deep sea creatures like, sorry, DL vertical migration and carbon sequestration. So what is this DL vertical migration and carbon sequestration? Let us understand. So deep sea creatures like zooplankton ascend at night in DL vertical migration for nourishment and safety. So there are deep sea creatures like zooplanktons which ascend to the surface, the top surface of the water in ocean. Okay, why are they doing this? For nourishment and safety. So this synchronized journey showcases nature's marvel and significantly influences Earth's carbon cycle. Okay, so this actually influences Earth's carbon cycle, which is very important. So how is it going to impact Earth's carbon cycle, that we need to know. So this DVM is a synchronized movement of marine organisms like zooplanktons, often seen in deep sea creatures as they migrate vertically in water column. So since the movement is vertical, it is called as DL vertical migration, and ascending towards surface at the night and descending at deeper levels during the day. So during the daytime, they will be at deeper levels. Okay, they will be at mesopelagic zone. But then during the night time, they will be going to the epipelagic zone. In the upcoming slides, we'll be differentiating these zones, the vertical zones of the ocean. Okay, so this pattern helps these organisms find food while avoiding predators. Okay, so they can avoid predators at the night time, and then they can have food safety there. Okay, showcasing a strategic survival tactic. So this is actually a survival tactics which is used by these organisms. So this is how it is done. Time of the day and then the depth here. Okay, so during night times, these two locations, during night times, they will come to the surface, and then during daytime they goes to the bottom. These green ones are phytoplanktons, on which these zooplanktons feed on. Okay, these black ones are zooplanktons. These are phytoplanktons. So these zooplanktons come to the surface to feed these phytoplanktons during the night time. This is what we need to understand here. Diel vertical migration. So at dusk, organisms from the mesopelagic layer, also called as twilight zone, rises to the safety of the epipelagic zone, thus capitalizing on the darkness to feed on the microscopic phytoplanktons while evading diurnal predators. Diurnal predators are the predators who are active during the daytime. Okay, and this synchronized migration, finely attuned to the natural light cycle, stands as the planet's largest biomass migration occurring daily across all oceans. So this is considered to be the planet's largest biomass migration, because a large biomass, that is these zooplanktons, migrate from one zone to another zone. Okay, so this occurs on a daily basis across all oceans. So these are all the vertical zones of a ocean. Okay, so we have epipelagic zone, which is up to 200 meter. Next is mesopelagic zone, which is up to 1000 meters, and then comes bathypelagic zone, also called as midnight zone. Okay, it is there up to 4000 meters, and then abyssal pelagic zone, which is up to 6000 meters, and above it every other thing is hadal pelagic zone, mostly deep sea trenches. Okay, so the average depth of ocean here would be 4000 meters only. Abyssal and hadal are rare here. Okay, so this is what we need to understand: epipelagic, mesopelagic, and bathypelagic. Okay, so these organisms from this region, from this zone, they travel to this zone, from mesopelagic to epipelagic. That is what we need to understand here. So DVM's role in carbon sequestration. How is this DVM, that is DL vertical migration of these zooplanktons during the night time, how is this going to help carbon sequestration? So organisms inhabiting mesopelagic layer actively extract substantial carbon from the upper ocean layers. Okay, so the carbon from the upper ocean layer is extracted by these zooplanktons while feeding on surface plankton transporting into deep waters. So they transport these surface planktons to deep waters because of their consumption. Okay, thus the carbon is taken to the deeper levels. After that, within the twilight zone, I mean within the mesopelagic zone, migratory animals contribute to the food chain also. They will also be fed by other animals, their predators, right? So these migratory animals contribute to the food chain, passing on the consumed carbon to their predators. So this carbon is then getting into the predators, and then the resultant carbon rich waste sinks to the ocean floor. The waste generated by these predators will be sinking to the ocean floor, becoming a crucial carbon sink, trapping carbon dioxide and aiding in atmospheric carbon dioxide concentration regulation. Okay, so this is how it is helping in carbon sequestration. I mean, this DL vertical migration is helping in carbon sequestration. Next is, what is carbon sequestration? We are talking about carbon sequestration, but do we know about how these carbon sequestration can be done? Okay, this carbon capture or carbon storage can be done. So carbon sequestration is the long-term storage of carbon in plants, soil, geological formation, and ocean. Okay, so it can be stored in plants, soil, geological formations, and ocean. How it is done, let us understand. And carbon sequestration occurs both naturally and also as a result of anthropogenic activities. Even we humans can increase carbon sequestration by planting more trees, or else by dumping carbon dioxide in oceans. Okay, and typically it refers to storage of carbon. Okay, so there are three types of carbon sequestration. One is terrestrial, another is geological, and then the next one is ocean that we discussed. Okay, so let us get into the details of those things. Terrestrial carbon sequestration. So the process through which carbon dioxide from the atmosphere is absorbed by trees and plants. So carbon dioxide is necessary for trees and plants, right? Because they do photosynthesis. So through the process of photosynthesis, trees and plants are absorbing carbon dioxide from the atmosphere. So this is one form of storage of carbon, okay? That is carbon sequestration. And it is stored as carbon in soil and biomass. Here the biomass here are tree trunk, branches, foliage and roots. In every other parts, carbon is stored, okay? So this is one form of carbon storage. Next is geological carbon sequestration. How is this done and where is this done? Carbon dioxide can be stored in oil reservoirs, gas reservoirs, unminable coal seams and saline formations and shale formations, okay? Those shale formations which are having high organic content are best for carbon sequestration. So this is how in geological formations this carbon is stored, okay? This is the second type. Next is ocean carbon sequestration, an example of which we saw in DL vertical migration, okay? So ocean absorbs, release and store large amount of carbon dioxide from the atmosphere, and this can be done in two ways. One is enhancing the productivity of the ocean's biological activity through ion fertilization. So here we are understanding a concept called ion fertilization, and it can also be done through injecting carbon dioxide into deep ocean, like we saw in the example of DL vertical migration, okay? So dumping of iron stimulates phytoplankton production. So how is this iron fertilization going to help in carbon sequestration? That is because when we dump iron into ocean, then it will stimulate phytoplankton production. When there is more phytoplankton production, they are the primary producers of the ocean, right, of the aquatic ecosystem. So primary production involves photosynthesis. So phytoplankton's production is enhanced because of this ion fertilization, which in turn leads to enhanced photosynthesis from these microorganisms, from phytoplanktons, thus helping in carbon dioxide absorption. So wherever photosynthesis is there, there is carbon dioxide absorption, carbon capture is happening. So in ocean it is done in two ways. One is ion fertilization, another is injecting carbon dioxide into deep ocean, okay? So this is how it is done, ocean carbon cycle, this is how it works, okay? These phytoplanktons photosynthesis is done, by this carbon dioxide is absorbed. Next is carbon flux is happening, okay? Particulate carbon flux is happening. And then we also saw zooplankton, which are there in mesopelagic zone. They come to the epipelagic zone to consume these phytoplanktons and take them to, take the carbon to the mesopelagic zone, and they will be then fed by other predators. The waste generated by those predators will be sinking as carbon, okay? So this is how the carbon cycle is happening. So ocean holds 50 times more carbon dioxide than atmosphere. This is what we need to know, okay? So these are all the facts that we have to understand from this particular news article. The topic that we are going to discuss now is noble pen shell or pinna nobilis. So what is this noble pen shell or pinna nobilis? It is a type of clam. So it is a huge clam. What is a clam? Bivalve mollusks are called as clam here, okay? So it is a huge clam that was on the verge of extinction, and it has made a comeback with a surge in numbers in waters of Croatia, okay? So earlier it was in the verge of extinction, but now it has made a comeback by increasing its numbers in waters of Croatia, okay? So the clam known as noble pen shell or pinna nobilis started dying out as a result of deadly pathogen spread in parts of Mediterranean around 2016. So around 2016 it was affected by pathogens in Mediterranean Sea, but then now it is recovering. That is why it is in the news. So the clams whose shell can grow as much as 1.2 meters across. So its shell can be as big as 1.2 meters in width, okay? And it plays an important ecological role by filtering seawater. So the role of these clams are filtering seawater and also allowing other organisms to flourish. And then they have been spotted across Adriatic and Styria Peninsula. So whenever you study about an organism, a new species in news, then where was it found, where was it discovered, that locational features, that geographical locational features are also important. Okay, so now here it is spotted across Adriatic and Styria Peninsula. So this is how the Pinna nobilis looks. Okay, so it is like a bivalve mollusk, a clam. Okay, and then it is found in Adriatic Peninsula. Okay, so this is the Styria Peninsula of Croatia. So it is found off the waters of Croatia. And then in the Styria Peninsula, here is where Adriatic Sea is here. Okay, so this is Adriatic Sea, and then this is that Styria Peninsula, and this belongs to Croatia. So such location and geographical features are also important. So with this, we have come to end of today's session. I hope you found the session to be very useful and informative. Let us see in the next session. Thank you.